What powers the aurora's glow? Why does the sky suddenly ignite with waves of green, purple, and red, as if the earth itself is breathing light? For thousands of years, humans have looked up at the night sky in awe, confusion, and wonder, as shimmering curtains of color danced silently above them. Some believed the lights were spirits. Others thought they were omens, messages from gods, or reflections of distant fires beyond the horizon. Today, we know the Aurora Borealis is not magic, but the truth behind it is just as extraordinary. In this video, we're going on a journey beyond myths and into the heart of space itself. We'll explore what the Aurora Borealis really is, how the sun plays a starring role, why Earth's magnetic field protects and paints our skies, and where, on the planet, you're most likely to witness this breathtaking phenomenon with your own eyes. This is the story of nature's greatest light show. Let's begin. Imagine standing under a dark Arctic sky. The air is crisp, the stars are sharp and endless. Then slowly the sky begins to glow. A pale green arc stretches across the horizon, growing brighter, taller, alive. It twists, ripples, and dances as if guided by an invisible hand. This is the Aurora Borealis, also known as the Northern Lights. The word aurora comes from the Roman goddess of dawn, while borealis means of the north. Together, they describe a phenomenon that appears like a celestial sunrise in the middle of the night. But what exactly is the Aurora Borealis? At its core, the aurora is light produced not by fire or electricity, but by energetic particles colliding with Earth's atmosphere. These collisions occur high above us, far beyond clouds and airplanes, in a region where space and atmosphere meet. The aurora typically forms between 80 and 500 kilometers above Earth's surface, in a zone called the thermosphere. Even though this region is extremely thin, far thinner than the air we breathe, it plays host to one of the most visually stunning events on our planet. But the story doesn't start on Earth. It starts 150 million kilometers away on the surface of the sun. The sun is not a quiet, gentle star. It is a massive, constantly churning ball of superheated plasma. Its surface boils with energy. Magnetic fields twist and snap. Explosions larger than Earth itself erupt without warning. One of the most important things the sun releases is something called the solar wind. The solar wind is a constant stream of charged particles, mostly electrons and protons, blasting outward in all directions at speeds of over 1 million kilometers per hour. Normally, Earth is shielded from this invisible storm. But when solar activity intensifies, things get interesting. During events like solar flares or coronal mass ejections, the sun hurls enormous clouds of charged particles into space. If Earth happens to be in the path of one of these eruptions, the incoming energy can dramatically amplify auroral activity. When these charged particles reach Earth, they encounter an invisible but powerful force, Earth's magnetic field. Our planet acts like a giant magnet with magnetic field lines extending from the South Pole to the North Pole. This magnetic shield, called the magnetosphere, deflects most of the solar wind, protecting life on Earth from harmful radiation. But near the poles, the magnetic field lines curve inward toward the planet. This creates natural entry points, funneling solar particles down into the upper atmosphere. As these high-energy particles slam into gases like oxygen and nitrogen, something incredible happens. The atoms become excited. When an atom is struck by a charged particle, its electrons jump to a higher energy state. But they don't stay there for long. When the electrons fall back to their original state, they release energy in the form of light. That light is the aurora. Different gases produce different colors. Oxygen is responsible for the most common auroral color, green. When oxygen atoms are struck at lower altitudes, they emit a yellow-green glow. At higher altitudes, oxygen can produce rare red auroras, often seen during intense solar storms. Nitrogen adds blues, purples, and pinks to the display. These colors often appear along the lower edges of auroral curtains or during particularly energetic events. The combination of altitude, gas type, and energy level determines the colors, shapes, and movement of the lights. This is why no two auroras are ever the same. Sometimes they appear as gentle arcs stretching across the sky. Other times, they explode into rapidly shifting curtains, spirals, and rays that seem to pulse with life. But the aurora is not random. Its shape and motion are deeply tied to the dynamics of Earth's magnetic field. As solar particles stream in, they follow magnetic field lines, creating symmetrical ovals of light around the north and south poles, known as auroral ovals. This is why the northern lights are most commonly seen in high-latitude regions like Norway, Iceland, northern Canada, Alaska, and parts of Russia. The southern hemisphere has its own version of this phenomenon, known as the Aurora Australis or Southern Lights. Though equally beautiful, it's seen less often simply because fewer people live at southern polar latitudes. The strength of an aurora depends heavily on solar activity. Scientists measure this using tools like the KP index, which tracks geomagnetic disturbances. A low KP value means quiet skies. A high KP value signals intense auroral activity, sometimes strong enough to push the lights far south into regions that rarely see them. During major solar storms, auroras have been observed as far south as the Mediterranean, Mexico, and even the Caribbean. But auroras don't just create beauty. They also remind us how deeply connected Earth is to the sun. In extreme cases, solar storms can disrupt satellites, GPS systems, radio communications, and power grids. The same energy that paints the sky can also interfere with modern technology. In 1859, a massive solar storm known as the Carrington event caused telegraph systems around the world to fail, some even sparking fires. Auroras were visible near the equator, shocking observers who had never seen anything like it before. Today, scientists closely monitor the sun, using space-based observatories to track solar activity and predict geomagnetic storms. These forecasts help protect astronauts, satellites, and critical infrastructure. Despite all our scientific understanding, the aurora still carries deep cultural meaning. Across history, civilizations have created myths and legends to explain the lights in the sky. In Norse mythology, the aurora was believed to be reflections from the shields and armor of Valkyries guiding fallen warriors to Valhalla. In Finnish folklore, the lights were thought to be caused by a magical fox running across the snow, its tail sending sparks into the sky. The Finnish word for aurora, revanchelet, literally means foxfires. Some indigenous peoples of North America believed the lights were spirits dancing or ancestors communicating from beyond. Others saw them as warnings to live honorably and respectfully. In parts of Asia, auroras were interpreted as cosmic battles between dragons of fire and ice. Even today, standing beneath an active aurora can feel deeply spiritual. The silence, the motion, the sheer scale of it all. It's a reminder that we live on a planet suspended in a vast, energetic universe. So when is the best time to see the northern lights? Auroras occur year-round, but visibility depends on darkness, weather, and solar activity. The best viewing seasons are typically from late September to early April, when nights are long and skies are dark in polar regions. Clear skies are essential. Light pollution is the enemy of aurora viewing, so remote locations far from city lights offer the best chances. Solar activity follows an approximately 11-year cycle, with peaks known as solar maximums. During these periods, auroras tend to be stronger, more frequent, and visible over wider areas. However, even during quieter solar periods, auroras can still surprise you. Sometimes the sky simply decides to put on a show. And when it does, it's unforgettable. The aurora reminds us that Earth is not isolated. We are connected to the sun, to space, to forces far larger than ourselves. What we see as beauty is often the result of immense energy, cosmic motion, and delicate balance. It's science in motion, art written in plasma and light. So, the next time you see images of the Aurora Borealis dancing across the sky, remember, you are witnessing the sun touching Earth, guided by invisible magnetic lines, translated into color by atoms in the sky. A reminder that even in the coldest, darkest nights, the universe is alive with light. And if you ever find yourself beneath those glowing skies, take a moment, look up, stay still, because you're not just watching lights. You're watching the universe breathe. If this video sparked your curiosity, take a moment to like it, subscribe to the channel, and share it with someone who loves discovering how our world truly works. And if you've ever seen the Northern Lights or dream of seeing them one day, tell us your story in the comments. We'd love to hear it. Until next time, keep looking up, keep asking questions, and keep exploring the wonders of our world.